Okay.
Good afternoon, sir.
Right. Okay. In the last class, uh, I was discussing about the HDLC protocol and two different modes for transferring the data between the two communicating devices. Then later, what kind of frames they have to use. So we have seen three different frames. So the very first one, the information frame, in short, I call the I frame, then supervisory frame, that is in short S frame, and unnumbered frame, that is U frame we have seen. And respective frames format we have seen, right? And so each of these frames format, we will be having the different fields, correct? So flag, address, control, user information, FCS, and again back the flag. And what it means, each of these fields we have studied, correct? And with respect to the each field, so flag we know that is a 8-bit sequence with a bit pattern starting with a 0 followed by 5 ones and 0, that indicates the beginning and the end of the frame. That's why for all the frames you can see at the beginning flag is there and at the end flag is there, right? And the second one, we need to suppose I'm sending a frame to a particular device, right? So I need a device name, right? So in terms of the data link layer, so I need the MAC address of the device, right? So that's the reason the second field is the address, right? And the third field is the control, right? So in all the frame, control is there. So if you want to control the flow of the frames, or to control the errors in the frames, right? Flow control and the error control, so those functions can be controlled using the field called the control field in the different frames, right? Then the next one, right? The in the iframe there is a one extra field that we call the user information, and this user information will not be there in other two frame, that is the S frame and the U frame. So user information in general, what you can think, they think that, so iframe is sent by only the sender. Okay, that's because it will be having the user information, or it will be having the actual data which the sender wants to send to the receiver. Okay, then the second, the last but one field called the FCS. So all the frames will be having the FCS because we have to detect the errors in the frames. So for that, we will be using the error detection technique called the CRC, cyclic redundancy check. So there we use the one kind of a bit patterns. So that bit patterns, what we call is the FCS, right? That is frame check sequence bit, correct? And finally the flag. So this is the for the complete I frame, and the S frame also includes this. In the U frame, little bit changes there. So here the user information. So here is the management information. Means suppose you want to establish the connection, right? So at that time we need this management, or you want to disconnect the link, you need that one, or you want to perform a one kind of a operation, for example asynchronous balanced mode operation or the function, then we have a one kind of a bit pattern here in the management information, right? So here everything is same, only the control field will be having the different operations or the functions. So and those uh, information also we have discussed in the last class, right? So in the control field, this is the I frame. In the I frame, the control field will be having the four different fields, correct? So the starting bit, that is the 0. So this indicates that it's a I frame. Whenever the starting bit is 0, that indicates the I frame. And you can see here in the S frame, starting bits. So 1, 0. So this indicates this is the S frame. And in the U frame, starting 2 bits, that is the 1, 1. It indicates the U frame. So these are the indicators to indicate the which type of the frame it is. U frame, S frame, or U frame. Right? And the second one, this is a very important one. So N of S, S indicates the source, R indicates the receiver. Okay, so N of S means number of bits required for frame sequencing. So here, usually we use the 3 bits. Similarly, here you can say the number of bits required by the receiver for acknowledgement sequence numbers is the 3 bits. That's why we have written n by n of R and n of S. So the middle one, that is the P slash F. P means a pole and F is the final. So this also has the, this is the only one bit. So 0 or 1. If it is 0, that indicates that the data is sending from the primary station to the secondary station. And if it is a 1, then it indicates that the secondary station data is sending to the primary station. So this is the correct, perfect. So the next frame we have seen is the S frame. So in the S frame, uh, we are having the, see here only the 4 fields, but here we are having the 6 fields. So anyway, I have said in the at the earlier, the starting 2 bits indicates that it's what type of a frame it is. So if it is 1, 0, it's a S frame. So we are not bothering about the starting 2 bits, are they starting 2 fields. And the next one, S. So this is the again the 2-bit field. So it has the 4 different patterns, 0, 0, 0, 1, 1, 0, 1, 1. So each field, right, or each bit pattern gives the some meaning. So if it is a 0, 0, that indicates the receiver is ready to receive the frame from the sender. And if it is 0, 1, it gives the information about the reject frame. And 1, 0 means the receiver is not ready to receive the frame. And 1, 1 is, so some data or some frame has received, but that is a error, or it is that is the errorly reached, and I want that that frame need to be resent. So that we call the selective repeat frame. So far we have seen the I frame and the S frame, and I stopped here only in the last class. Now we will see the U frame, right? So in the U frame, the starting 2 fields, 1, 1, it indicates the, this is a U frame, and the MM and MMM. So these are the 5-bit codes. Anyway, we know P slash F, and the remaining these 2, right? So this is the one kind of a code, correct? And these 3 fields. So total we are having the 5 bits, correct? So these are the 2 bits and these are the 3 bits, right? So unnumbered frames are used to exchange the session management and the control information between the connected device, right? So unlike the S frame or the I frame, the U frames contain the system management information, but not the user data. So that is a very important thing. Here, only the user data won't be there. Here, we will be having the system management information, but not the user data. So this is a very important here. Even in the S frame also, we won't be having any kind of the system or the user data. will not be having anything. It's just you can think of this is the receiver is sending this information, this frame, right? Good. So here, as I said, here it's a 2-bit, correct? This is a 2 bits, and here I'm having the 3 bits. So this is the 2 bits, and this is the 3 bits, right? So this we call the prefix 2 bits, and this we call the suffix 3 bits. And this total 5 bits will create up to how many different types of frames? 32, correct? 2 raised to 5. So 32. So 32 number of U frames will be created by the by this code, this 2-bit and the 5-bit code, right? And these codes, right? So total I will be having like 0, 0, 0, correct? And 0. So 1, 2, 3, and 5. So I'll be having till 1, 1, 1, 1. So like this we'll be having, correct? So I'll make it as a dot, correct? So total 2 raised to 5. So 32 bits, correct? And each of them, for example, so 0, 0, 0. So this indicates a one kind of a particular function. That is a we have seen, right, the different modes of the data transfer. That is a normal response mode. So it might be the NRM, correct? So this will be the one. And the second, right, suppose here you will be having the 0, 0, 0, 0, 1, correct? So this will be having the second mode, ABM, correct? So like this, I'll be having a few more. For example, here, maybe some bit pattern. So maybe you can think of as a connection. Sorry, here, this bit gives the information about the connection establishment. Connection establishment. Submit. And you can think of the other uh, management information, something like disconnection. Disconnection. Correct. So this is the one kind of, and you can think of the some other functions also. So these are the functions are the management system management information, right? What kind of are the one more thing, the control informations. See, connection establishment, data transfer, disconnection. So these are the control information, and the data transfer. So what kind of modes the system the device has to adopt? Maybe they can adopt the NRM, or they can adopt the ABM. So these kind of functions will be there in these 2 bits and these 3 bits, right? So these are this is about the complete the frames and the different control fields of these frames, different operations, right? So actually, we in the real time how it will happen. Just we'll see with one example. So this is the, say this is the sender. Right? This is the sender, and this is the receiver. So sender is there and one receiver is there. So and we are having the timelines like this. This is the timeline, and the receiver also will be having the timelines like this, correct? So the first frame, right? So the first frame, it will be like, can you tell me what will be the first frame? Can anyone tell? Students? So we are having the three different frames, right? I frame, S frame, and the U frame. So suppose the sender wants to send the data to the receiver. So what will be the first frame before starting the data, transmitting the data? Please, can anyone tell me? Sorry, can you repeat?
Sir, don't know.
Don't know. Okay. See, we have seen here the different functions of I frame, S frame, and the U frame, right? So as I said, this is just for transmitting the data, and this is for the acknowledgement control information I'm saying. And this is for establishing the connection, disconnection. So before transmitting any kind of a data, we need to establish the connection, correct? So the first frame will be the U frame. Okay, so U frame will be there, and I'll get a response from the receiver, right? So response will be what? Which frame will be there in the response?
The rest frame.
Yeah, good, very good. So in the response, it will be the S frame, because in the S frame, we are having whether receiver is ready to receive or not, right? If it is ready, then, or if it is not ready, also the S frame will be coming back. So once it is done, then actual information need to be transferred, and that actual information will be transferred by using the iframe. And suppose I have done the transmitting of my all the data and I want to disconnect the connection. So at that time, I need the last frame, that is the U frame. So this is how actually it in the real time it will work like this. Okay, so this is what, and yeah, I'll give you the one more example with respect to the control field, especially the S frame, because in the S frame I'm having the different kind of operation. So I'll give the example in this. So S frame. So as I said in the S frame, so we'll take this field need here. So what I will do is I'll remove instead of S. Okay, I'll give the 0. Sorry, 0, 0. Right. And n of R. So as I said, n of R is a 3-bit. Right. I'll use this. Just expand. So actually how it will happen. That thing I want to show. Good. Okay. Suppose it's a 1. And this is like 0 and 1. And it's a 0. So can anybody tell what is happening in this control field? So suppose this field is exchanged during the communication. So what exactly is the function going on between the S and R. Same diagram we will take.
Sir, I'm not sure, but is the receiver telling like it's ready to receive the final frame?
Yeah, yeah. One is good. It is ready to receive. The second one, you said that receiver. So because here it is a one, so that's a receiver. And what about this 0 1 0? That means what? So 0 1 0 is what exactly is the number? This 0 1 0.
5.
No, 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 no. 0 1 0. Only 3 bits. I'm saying 0 0 0. Right? 0 0 1 and 0 1 0. So this is the thing I'm having, right? The last one. Correct? So according to this bit pattern, I'll just make a bold. Good. So according to this bit pattern, the what receiver says after receiving this is after when it sends this field, right? This complete field or the control field, I have successfully received 00 and 001 frame, and I'm expecting for the 0 1 0. So I'm expecting for the second frame. This is the 0th frame is successfully received. 1th frame also successfully received. Now I'm expecting for the second frame. Understood?
Yes, sir.
Okay, good. So the next one I will give same is frame only. So I'll make this as a 1 0, and the same thing if I keep. So what does it mean? So what does it mean? This. So 1 0. So this indicates the S frame, and 1 0. What is the meaning of the 1 0? 1 0 meaning is receiver not ready, right? So the first frame has come here. So I'll just remove here and I'll write F0. F0 means 0000. And here I have received the acknowledgement A1, and frame F1 I have sent, and it is expecting for the A2. And now I'm sending the 8 F2 here. F2 I'm sending, sorry. Yeah, F2 I'm sending, right? 0 1 0 is the F2, correct? This is 0 0 0 0 1. So I again make it clear. This is 0 0 0 first frame, and this is the 0 0 1, this second frame, and this is 0 1 0. This second frame I'm sending. So it receives and it will send back the acknowledgement here. An acknowledgement will come. That is the NACK. So in the NACK, so this complete control field will be there. So what it says is, I'm not ready. According to this field 1 0, the receiver is not ready for receiving because whatever the buffer or the whatever the storage, whatever the receiving rate it has, okay, that has reached its limit. Now I don't have space to store that frame, right? So in order to tell these all information, it will just make the 10 here. So that after seeing this 10, then it will slows down the sending rate the sender using this negative acknowledgement or using this complete control field. Understood?
Yes, sir. Sir, what does that fifth box number mean?
1, 2, 3, 4, 5. This, yeah, this is the I said right here P slash F. P slash F. So if it is a 0, indicates that sender is sending the data to receiver. Sorry, to receiver. And if it is 1, that indicates receiver is sending some data to the sender.
Yes, sir.
Okay.
Okay. Thank you.
So now we'll take the one more example. Whatever AR key we have studied, right? So those things I'm going to realize using these bit patterns. Now I'm having 1, 0. Here I'll make 0, 1, 0, 1, and I won't specify here. So both the communication will be there. Okay, let it be 1 only. Anyway, I'm presuming that receiver will be sending the data. Then I'll make it is 0, 0, 1. Okay, it's yeah 0, 0, 1. So here I have taken the second operation 0, 1. So we'll go back. We'll see what is the 0, 1. Reset the frame. Okay, so uh, uh, 0, 1. I have sent the reset the frame. Right, and this 0, 0, 1 again it indicates that receiver has received the first 0th frame. So this has received this. So according to here, so this 0th frame, the receiver has received successfully, and it is waiting for the second or the first frame, expecting the frame 1. So like that it is. So this timing diagram, I will show you. Yeah, it's expecting for the F1, and F1 the receiver has sent. Receiver has sent, and I'm presuming that F1 is the error. So, and it's a error packet. It has received, and F2, F2 I'm saying. Anyway, the acknowledgement will be coming back here. So it's not a stop and wait protocol. Okay, because stop and wait protocol, it will be used only for the 1 bit 0 or 1. Here I'll be using more than that, right? And uh, if at all, if I use the go back n, correct, go back n. So receiver, what it is expecting is, it is expecting the F1 frame, and it has not reached, and it has sent the F2 also, but expectation is the F1. So has receiver is expecting the F1, so F2 it has reached, but what receiver it does is it won't accept this F2. Okay, F2 it won't accept because it was waiting for the F1 and F1 has not reached. So this negative acknowledgement will be going back. Suppose this acknowledgement will be delayed. This acknowledgement will be delayed somewhere here. Here it is there, delayed acknowledgement, and this acknowledgement has received here. Suppose here, right? Negative acknowledgement has received, right? And this negative acknowledgement, what it says is, I'm waiting for the, I'll write the A1. So I'm waiting for the frame 1, right? I'm waiting for the frame 1 to receive. Then only it will send that frame 1. So here, this complete setup will be working as a go back in. Go back in ARQ. Because here, though F2 I'm receiving, though F2 the receiver is receiving, but it is not accepting that one. Okay, the F2 is not accepted here. I'll write that F2 is not accepted by R because F2 was waiting for the F1. That's the reason it won't accept, and it will send a negative acknowledgement to resend or retransmit the frame F1. Then it will send the F1. Right? So this is the reason this complete working model will be working as a go back in protocol. Understood?
Yes, sir.
Okay, fine. And the one more will be there, that is the selective repeat. So you can analyze in this way, the way I have done it here. So like this, you can analyze it for the other two. Good. And I have done one small mistake while explaining this uh, complete problem. So I'll just correct that problem. So this problem, right? I said that 10% activity factor and 90% activity factor. So I gave the wrong, there's a wrong answer here. So I want to delete the complete. So here, what I wanted to tell is, so 1 Mbps link is there. I'm having the 1 Mbps link like this. This is the complete 1 Mbps link. And there are few systems are connected. Few systems like this, they have connected. So it's connected here. This one. And this also, and so on. So like this, many systems will be connected to this 1 Mbps link. So I'll write it as this is the Mbps link. Right? This is the 1 Mbps link is there. And so each of these devices, right, they can be active only 10% of the time. Only 10% they can active. All. Right. So 10% can active. And 90% of the time these all systems will be inactive. Okay, so the now question is, if you use the circuit switching, right, how many users can access this link, right? So how many users can access the 1 Mbps of the link? So that's the question I asked in the earlier class, right? So as I'm saying, it's a circuit switched network, means there will be the dedicated link established, right? This is the complete dedicated link from suppose A, it's a, correct? Suppose this is a A, and this is the B, and this is something like C, and so on. Maybe you can say the K. So I'll see the three dots. So like this are there, right? So can you think how many numbers of devices can be connected to this 1 Mbps link with having the 10 activation? So each of them, how much will get the data? I mean, how much of 1 Mbps link, how much they can access it? So I'm having the 1 Mbps link. So for this 1 Mbps link, I want to share with a certain number of devices, right? So how many number I can share? So that's the first question. So for this, see, as I'm saying, circuit switch network. So if you give the same for all, right? Same for all the devices. So for example, if I give the 100 kbps, okay. So I want to give the 100 kbps to this guy, 100 kbps to this guy, and this, and this, and so on. So how many numbers of users can get 100 kbps? So if you do the 1 Mbps divided by 100 kbps, so you can get the maximum, at the max, you can assign to 10 users. Got it? 1 Mbps link is there. And for all the users, I want to assign the 100 kbps, and at the max, you can assign to 10 users. So this is the circuit switch network. So no issue. This is the maximum I can assign. What about the packet switching? In circuit switch, it is a dedicated. So this 100 kbps cannot be used by the other devices, or the B's 100 kbps cannot be used by the other. Even though the A doesn't have any data, right? And any data also, he can access the 100 kbps of the link or the bandwidth. So that's the wastage. So in order to solve this problem only, we have gone to the packet switching technique, right? PSW. So there, anyone, whenever you have the data to transmit to the send receiver, then you can access it. And if you don't have, then you cannot preserve or lock the complete bandwidth, right? So, so you need to solve it for the packet switching. So there you need to use the binomial theorem and simple probability concept, which I have told in the last class. I have given a few steps, right? So same steps you need to follow here as well. Okay. And I give the one more few things which are related to the problems. So for a n-bit frames, n-bit frame, I'll make it bold so that you can see clearly. So this is for n-bit frame. What is the probability the probability of 1 bit error. So in the frame, so this is a complete frame if you think of, and it has the n bits. It has n bits, right? So what is the probability of 1 bit error? Can anyone tell? What will be the answer for this? I'm having the n bits and I'm asking what is the probability of 1 bit? Only 1 bit. So it's like n choose 1 into p. If you are considering the p is the 1 bit error probability and 1 minus p is the non 1 bit error, right? So it's like n choose 1 p into 1 minus p raised to n minus 1. Right. Similarly, in general, if I ask what is the probability of j bit error? So there, same like instead of 1, we need to put the j. N choose j p raised to j into 1 minus p raised to n minus j. Okay. So,
Sir, could you please write that down?
okay. Probability of 1 bit error equal to, I'll write n choose 1 into p into 1 minus p. It's a small p raised to n minus 1, right? 1 bit error. So this p is the probability of error and 1 minus p is the not a probability of error. Got it? So this is the one formula. And you can, in general, if I say what is the probability of j bit error? Same thing, whatever we have written in the above, instead of 1 bit, I ask the j bit. So that is a generalized one. So n choose j into p raised to j, correct? Into 1 minus p raised to, sorry, where is this? Yeah, n minus j. Got it right?
Yes, sir.
Suppose if I ask, or in general, the bit errors are random, right? And I'm having the bits something like this. I have generally set the 1 bit there or the n bits there, and I'll be having like this 1 0 0 probability of 4 4 3 0, right? 1 2 3 4. Yeah. So probability of 1 followed by 7 zeros. So what is the probability of error? So if you are the basic assumption here is 1 is a 0. I mean, sorry, 1 is a error and zeros are the non-errors. So here it's p into 1 minus p raised to 7. Similarly, if you write 110 and 4 zeros, yeah, 2 ones followed by 6 zeros is the probability of 2 ones followed by 6 zeros. So simple, p raised to 2 1 minus p raised to 6, right? So like this. And you can again you can think of something like what is the probability of patterns with even number of ones. That's very interesting. Probability of error patterns with even number of ones. Got it? So here in this, okay, I'll write what is the probability of even number of ones. Even number of ones. So this is again a very interesting one. Here you have to write the probability at the even places, right? So two is the even place. So here you have to write like n choose 2 p square into 1 minus p raised to n minus 2. Do you want me to write or it's okay? Students.
Sir, please write.
Okay. N choose 2 p square 1 minus p raised to n minus 2. This is a 1. Again, I will be having like the second place. So next is the 3. 3 is not even, it's odd. So again, I have to go for the 4. So n choose 4. Then p raised to 4 into 1 minus p raised to n minus 4. Sim again the plus 5 is the odd. Then we have to go for the 6 and so on. So you can put a just dot here. Even numbers. Or the something like this also the you can solve it. What is the probability of at most one error in the frame? At most one bit in the frame, right? So this kind of problems also you can solve it. Because why I am emphasizing more, because in the cat 1 I won't give any theory related questions, but what I will be doing is whatever we have learned in the theory, so that I'll be asking in terms of the problems. Okay, so should be very careful while answering to the question. Any questions so far? So for the cat 1, the module 1 complete, and till the HDLC module 2. Okay. And I have uploaded all my videos in the YouTube. You can watch it there, and I have already shared the link as well. So whenever you get time free, you can just visit to the YouTube link. Okay. Any doubts?
No, sir.
Okay. Okay, fine then. Now let's stop.